Welcome everyone to today's webinar on the topic of State of Industry 4.0 adoption, the technologies and use cases that create value. My name is Knut Lasselüt. I'm the CEO here at IoT Analytics, and I'll be guiding you throughout today's call. Before we begin, I want to quickly do a few housekeeping items. So first of all, the webinar will be recorded and it will be made available to you a few days afterwards. So I've already had a few questions on this. You will get the recording. Second of all, there will be a moderated Q&A at the end of the session. You can submit your questions at any time using the Q&A button, which you can find at the bottom of your screen. At this point, all attendees are muted. Should you have any issues seeing or hearing us, please use the chat box and send us a message. And with that, let's get started. Very quickly, I will run you through the webinar content. Then we will introduce the topic of Industry 4.0 and smart manufacturing, give you a view on what we see as the state, as well as the successful implementations, the research view. And then we will hand over to Raphael, who works with Jellix, who is involved in a lot of these projects, who will give us an overview from his side, as well as the project organization and the KPIs that make a project successful. And finally, like I said, the Q&A. So very quickly about the speakers. I've been working on IoT and Industry 4.0 related research for about 10 years now, and I'm the CEO and founder at IoT Analytics. With me today is Matt Wapata. He's our topic lead for industrial IoT and Industry 4.0. He's a lot more technically oriented than I am. And like I said, we have a partner on the call today who comes much more from the implementation side of things. When we discussed with Raphael, it was clear he's involved in a lot of the actual projects, and we thought together the research view and that implementation view make for a very good and compelling webinar. And that's why we're doing it today. Very quickly, if you don't know IoT Analytics, we are a leading market research firm for the Internet of Things and Industry 4.0. We work on a lot of market reports, some of which we will, some of the data of some of these reports which we will show today. We also provide research services, and you may have seen some of our recent webinars. We had one on IoT data management and analytics last year, on cellular, industrial IoT cellular connectivity. We will have one on edge computing analytics later this year. And on the right-hand side, you see some of the reports we recently published and some of our upcoming reports. The main goal of today's webinar is to equip you with data and insights that help you or your organization either implement or market Industry 4.0 related projects and or technologies. And with that, I will hand over to Matt, who will introduce the topic, and we will get started.
Thanks, Knut. So first, we want to have a quick introduction to Industry 4.0. I'm sure many of the people on this call are familiar with the term, so I won't dive too much into detail here, but I think it's important to understand where we're coming at from our market model and just overall what the Industry 4.0 market is. So the term originated in 2011, and it was originated in Germany and introduced at the Hanover Messe, and it encompasses the trend towards automation, data exchange, cyber physical systems, IoT, cloud computing, and other related technologies. And it's often used synonymously with terms like smart manufacturing, smart factory, and industrial IoT. But it's not, in our view, synonymous with IoT, and we'll explain that on the next slide. Well, could you go back one more slide just to kind of highlight the trend of Industry 4.0. So you can see it was introduced in 2011, but this Google Trends graph on the right shows how it's just taken off, especially since 2013, in growth and popularity over time. So it's definitely something that's on the top of the mind for a lot of vendors and end users. So we wrote a report on Industry 4.0 in 2018, and in the process of doing that, we developed this definition that you see on the left-hand side of the screen. So while it does incorporate some Internet of Things technologies, it's only focused on the Internet of Things technologies within the connected industry vertical. And the Internet of Things spans many verticals, as you can see on the y-axis on this chart. But it also includes other supporting technologies that aren't necessarily Internet of Things. And so we identified 6 supporting technologies that you can see on that graph there that have a wider technology scope than IoT, like additive manufacturing, AR and VR, and others. And those technologies can be applied in sort of 2 different fashions in an Industry 4.0 deployment. And that can be either smart products, which are IoT-enabled products and equipment in the field, or smart operations in production, or smart factories, which is the use of Industry 4.0 technologies within a particular manufacturing or production environment. And it's with this kind of definition that we came up with these 3 sort of elements of Industry 4.0. So the connected industry building blocks, or the IoT related building blocks that are part of that IoT portion of the Industry 4.0 market. And then the supporting technologies that all 6 are highlighted here are the additional technologies that have a wider scope than just IoT. And together, these 2 components of Industry 4.0 enable a number of key new use cases. And we highlight 5 here, but we highlighted a total of 12 in the report. And it's with this framework that we developed our market model. And we will look at that here on the next slide. So we can go ahead and go to the next slide here. So this is the market model that we came up with for the Industry 4.0 report that was released in October 2018. So the data is a little bit dated, but it's still, I think, holds. And you can see that the 2 components of the overall Industry 4.0 market are these connected industry building blocks and the supporting technologies. And so together, both of those elements of the Industry 4.0 market grew at or projected to grow at a growth rate of 37% to get to an overall market of over $300 billion by 2023. And so when we did this report, we wanted to take a deeper dive and see how end users are actually adopting and applying these different Industry 4.0 technologies. And that was the basis of this report that we put together that we'll be going over the results with you today on. So we interviewed 150 end users about their adoption of these 17 different technologies. And if you go to the next slide, Knut, we've outlined the 17 different technologies that we asked the end users about here. And you can see that the 6 supporting technologies, plus many of the components of the connected industries building block stack, are all mentioned here, as well as a couple of other emerging technologies like blockchain and quantum computing, which weren't considered in the model that we did in 2018, but we wanted to get a feel for how they were being adopted in practice. And so with that, I will pass it over to Knut, who will go through these results and see how the end users are actually deploying these technologies today.
Thank you, Matt. The first thing that we looked at, obviously, is the global Industry 4.0 adoption rate. The way we defined it was we looked at those technologies that you just saw on the previous slide, and we asked these manufacturers, to what degree have you looked at these and do you have it rolled out? And the ones that are fully rolled out or extensively rolled out, we counted. And if you look at it from that angle, it's only 28% of the technologies that are rolled out on a larger scale, so to say. And this resonates very well with what you see on the right-hand side. Some of the quotes that we received is people are saying we're at the beginning stages of enabling pervasive shop floor machine and handheld gauge data collection. We're in the proof of concept stage for edge computing. We're currently testing cobots. These are the typical things you hear from various manufacturers around the world right now. So the picture that Industry 4.0 is not adopted at a very high level yet is something that you can see globally. Although, when we did this analysis, we realized that the manufacturers in North America seem to be ahead compared to the ones in Europe, again, compared to the ones in Asia Pacific, where we had a specific focus on China. So about 70% of the responses. So the data is about a third when you look at these different regions, and the data coming out of Asia Pacific and is about 80% China. So for a lot of people, maybe not surprising, because there's been a lot of articles that North America might be ahead. Our data supports that. There have been some studies saying Europe is ahead, but again, this is our survey data. There are some interesting, when you look at the details, there are some interesting things. So for example, cloud is something where the ratio or the rate of adoption in both Europe and North America is around 80%. When you look at Asia, it's more about 40%. So there you see some very strong differences. And we could go into much more detail, but on a high level, that's one of the main findings. Now, when we look at those technologies that Matt just showed, it also became clear, it becomes very clear from the data that some of these are really important to some organizations. So what we're comparing here is the average penetration. So what percentage of companies are saying we're using and paying for this technology versus how much are they actually paying. And so you see on the top right here that cybersecurity, cloud, IoT platforms, that those technologies that we asked about are extremely important with both a high spend and high penetration. Then there are some technologies which are cost intense, but are not implemented in a lot of organizations. That's 3D. That's the bottom right. Everything from 3D printing to 5G. There are again other technologies which are a lot more cost light, but widely adopted. That's machine vision, AI, edge computing. And then there are those that I would classify as they haven't really had their breakthrough yet. Augmented reality, virtual reality, blockchain, drones, and a very, very small thing there, quantum computing. I know we've had some comments of people saying, is that really Industry 4.0? Well, we wanted to understand what's going on. And, you know, it paints a very clear picture of what are companies focusing on and what are they not focusing on. Obviously, the topic of this webinar is where's the value? And first of all, do these technology investments create value? And the answer is very clearly yes. So 78% say positive ROI from investing in these technologies. Another 27% say they achieve amortization of that investment within 12 months. So that is a very strong case for Industry 4.0 and for these technologies. When you then look at, well, which technologies do you get the biggest ROI from? There's various ways of looking at it. So we looked, for example, here at which of these are amortized the quickest. You could also look at it on the right-hand side, which is which of these have a negative or zero ROI. But if you just look at the quick amortization, you see that machine vision is clearly the one technology where people are saying we really get a lot of value out of that. Digital twin, and then a couple of those more capital-intense technologies, which not always make sense for every industry. Automated guided vehicle, cobots, 3D printing. Very, very much in line with what we just saw on the matrix chart. Technologies like blockchain, AR, or VR have not only rather limited investment, they also have a rather low ROI, and that's probably correlated. Now, so much about the state. Let's look at what it takes to implement and what people have told us from a research point of view. When they implement these technologies, what exactly do they have in terms of tips and tricks, and what are their challenges? So first of all, pretty much everybody says they have major implementation challenges. So you can see this on the left-hand side. Then when asked, what exactly are your challenges? There is a clear, I don't know if winner is the right word, but there's a clear number one, and that is missing talent and skills. And so this essentially breaks down into various elements, but a few years ago, I think interoperability would have scored a lot higher, but now it's really about the people are either not trained or they're not there to actually implement this. And when you go a little bit deeper into the data and you break that down, you see that first of all, this is a global problem with, from a regional point of view, being the strongest in Asia Pacific. And keep in mind, this was a very China specific view. Just to I didn't mention this beforehand, but the survey and the data we did this at the end of 2019. So if you want to kind of look at coronavirus, wasn't a topic at that point. But Asia Pacific has a very strong skill gap. It's across all different kinds of sizes of company. And then in our data, it shows that automotive is perhaps has the lowest problem with this, whereas industries in the process industries like oil and gas or chemicals or computer, electronic, and electrical equipment have the highest problem with not finding the right labor. One other thing about implementation and making it a success, we obviously asked, so what can you share with us? What makes implementing Industry 4.0 a success? And one of the findings was only 1 in 10 people mentioned anything that was technical. So most of the things that people said were important were not about technical aspects, but about people and economics. So there's a quote here. It's as much about communication and the culture behavior as the technology. Look for the advantages and explain how they help the people who will be deploying and adopting the technology. On the right-hand side, you can see some of the success factors that were mentioned the most. So perhaps not surprisingly, the #1 challenge is the skill gap. The #1 tip is invest in your own people and invest in training them. And do it early and do it well, and don't just do a little bit, do it extensively. The second thing that came out quite a bit was don't just do anything, try to calculate an ROI and clearly define what you want to get out of this, which is connected to the third aspect, which is it's about the value proposition and the use case, and do focus on the customer needs. And maybe just to explain why these are so, there's 3 or 4 different categories. We had people say exactly what they wanted to say. We didn't give any categories predefined because we really wanted to understand what came out. So we clustered them afterwards again with the answers we received. Fourth aspect is about change management and a communication strategy, particularly in larger organizations. And also very important to really have this on the top level, the buy-in from the executives on the top, and not just a team at the bottom, because it's such a big undertaking. We have a couple more quotes here that we could share with you, but I think in the sense of time, and because we also want to kind of get to, well, what does the actual implementation look like? What are the use cases? I will skip through that here right now. And maybe last aspect, one of the things that came out of this research was we also asked people, obviously, who is really good at implementing it. And here are 4 of the factories that were mentioned several times, where people said, well, I've either been here, I've seen them, or I've heard about them. And this is where Industry 4.0 is put to work in a very good fashion. And maybe just to share a couple of notes there. So Tesla, for example, obviously is known for their high degree of automation in their Gigafactory. Boeing in Everett is often mentioned for the digital twin they have with the plane and how they're optimizing that. And then BMW on the bottom right, they are very early in testing 5G, and they're having a holistic logistics concept as part of many other initiatives in their largest plant in Dingolfing. And then Siemens is known for really implementing Industry 4.0, their own technology on their own production of products. And I think this is the plant where they produce some of their PLCs. With that, maybe if you are interested to learn more about this research, you can buy this report online. If you're not already a subscriber, there's a discount for people on the webinar. And if you're interested to learn a little bit more about our publications and potentially receiving access to all of the data that we have, you can either send us an email or you can just type in the Q&A section here of this webinar that you're interested in, and we'll get in touch. And with that, I will hand over to Raphael, who will now tell you a little bit more about the practical side of Industry 4.0.
Okay. Sorry about that, just out at the beginning. Okay. So thanks a lot to the people at IoT Analytics who gave us the opportunity to give a little bit some aspects about our company and our solution. I will start with a quick introduction about our company. The company is named Brütsch Rüegger Tools, and we are based in Switzerland. We are a global company, and our main business is providing tools for the industry. So we have a full product range of 200,000 different items. We have a delivery capacity of 99%. And of course, we try to deliver all our orders within 24 hours here in Europe and 48 hours globally. And we have also some extensive range of services around our items. So how I said, this is our main business, tool distribution. We have more than 15,000 products coming from 900 different suppliers, and this is our main business. But it will not be the main topic of today, because I will try to explain you just how did we move from a tool retailer to an integral solution provider. So first of all, when we started for more than 140 years, we had contact to the people really from the shop floor, so from the manufacturing side. And we were talking about tool performance, the cost of these tools, the efficiency. And at that time, we tried to deliver the best solution for it. So we have built up our logistic and our assortment. We have built up some tool services around all our products. And we try to focus on manufacturing and technology. But in year 2000, it started to change a little bit, and it was already going in the direction of digitalization at that point. A lot of procurement or logistic people at our customer came to us and say, okay, we want to talk about the process cost. We want to talk about the contract compliance. And we had already at that time to try to change our, I would say, our business model, because we started to digitalize our service with a web shop for the distribution of our products. That was in 1999. Then all talking about also the flexible data management, transaction management, so to optimize the whole process. And that was the first step into this digitalization. And in 2012, we entered into a new era where we decided to create a new business unit for all what about consulting. So the management of our customer came and said, okay, we want to increase the efficiency of the production process at our factories. We want to focus on the core competencies that we have, and we want to work on that. And we think that BRW can help us in this direction. So we set up a full range of new services around the tool logistics, the Industry 4.0, the IoT technology. That was also at that time a technology that we have found and estimated as a potential for providing this solution to our customers. And that was the beginning of Jellix. So what is exactly Jellix? First of all, I have to say it's an alliance of key players in the manufacturing industry. So it's not only a BRW solution. Of course, we manage the whole thing, the whole ecosystem and the platform itself, but we try to work with a lot of different, I would say, smart product provider or brands or machine manufacturer who also will use the Jellix platform to provide some new kind of services. The mission of Jellix is really to deliver industrial applications on a common and open platform. So then any company can access the best digital tools to improve its performance. So it's really a solution also for, at the end of the day, for the end customer to try to optimize all these aspects linked to the Industry 4.0 and the digitalization. And if I have to split our know-how in three main categories, I would say, of course, the main is the platform, the Jellix core. This is really the platform, so the software solution that we will install at the customer side, or we can also run it on the cloud, but it doesn't matter. Today, a lot of customers still want to stay on premise, so this is the core platform. But beside of that, we have the apps. So it means with the platform itself, you still have no added value because it's a platform as a service. You will use it to enable the applications for the business know-how. And then the third aspect are the partners. That are the people or the companies sitting behind this platform, providing solution, providing services on the Jellix platform. So this is really our know-how split it in three main, I would say, units. And Jellix is not only the platform itself, how I said, it's also an ecosystem. So Matt talked about two main categories in the industry for all. It's the smart product side and it's the smart operations. And on our side, we talk about also smart product and smart factories, which is comparable to the smart operation. And they are based, all of this solution are based on the platform itself with our technology, our application, the development side, and the connectivity side. And this is supported by our partners. So, I mean, we work, how I said, with a lot of different companies which are splitted in these different categories. So we have technology partner, we have app provider, so really company who has maybe a smart product and who want to provide an application on the Jellix platform. We have the integrators and we have the consulting company which use our platform to enable some solutions. And at the end of the day, on top of that, we have the marketplace. The marketplace is not more than, I would say, a showroom where all the applications are available to download, but also where you can find all the description and what you can do with it and all the information linked to it. So, of course, we will never be at the state like an app store from Apple, for example, because our application in the industry needs always some integration. It's not just download and start it, but we try to go in this direction anyway. If we have a look at the platform itself, so not going really into the details, the technical details, but we can see at the bottom of the screen all the things. So we talk about IoT, so Internet of Things, and at the end for us, the things are the equipment that we can find in a factory. So it can be a machine tool, it can be a measurement tool, robots, sensors, all kind of equipment generating data. Then we still have a lot of customers working with flat files. So I think today one of the most MES system is still Excel. So we'll find a lot of Excel documents to the customers. So we have to be able also to get the data out of it. Then we have the database. So database linked to a software or linked to a, I would say, personal solution that was developed internally by the factories. So all of these are also data sources where we have to take out the data. And on top of the screen, these are the solutions which will be enabled with all this data. So of course, we are talking about dashboards or standard applications, just providing the information to the people, but we also go in the direction of creating special reporting solution, alerting, and interface more based on the customized solution for our customer. But let's just talk about the smart product and the smart factory. I will try to bring some use cases here in this field. First of all, smart products. If I have to take an example of a smart product, I could talk about this company, which is the tool manufacturer of torque wrench, and they have a tool which is today able to control and who also deliver data through a standardized communication protocol. So we have connected this tool for this manufacturer, and we have enabled the solution with a lot of functionalities linked to a software. So the software is not only to get the data out of the tool, but it's also a solution in the direction of a worker guidance. So it's getting the data out of the tool, sending data to the tool to help the operator to use the tool at his maximum efficiency, but he's also trying to bring a business process behind of it. And of course, we enable a lot of setup and connection parameters through a mobile application because, of course, working with web technologies and the IoT platform allow us also to use smart devices because we are not linked to an operating system, which just can use our data and make them available on every kind of devices. So that was the fact in this case, giving the opportunity to the operator about giving some parameters or set up the tools via mobile application. So this is more a smart product use case with all this kind of interface, which is created to be as easy as possible because we are all now always using our smartphone and everything is easy. So we try to bring the same in the industry right now, not creating complicated solution, but just trying to do some kind of plug and play solution. And now jumping into the smart factories, I have another example of a company which is called Tech3, based here in Switzerland, and the company BRW. So we act in this case as an integration partner. So we have integrated our Jellix platform over there, and we have enabled some application for the Shopfloor management and different kind of other needs. So just small overview. So we have here production machines, so machine tools, about 30. We have 24 employees, so it's a small company, but nevertheless, it's a company who has decided to go in the digitalization direction, and they did a lot in the last 3 years. For example, in this kind of industrial implementation of the manufacturing of the precision parts on these machine tools, the operator has full access to the data via the smart devices. So he is able to check a lot of information coming from the equipment. Of course, all of these data are aggregated together to really generate high value KPI. So he can get access to this data, and he has also access to give some information to the system, because of course the equipment will not deliver all the data. Some of them has to be indicated by the operator. So we also have a kind of input peripheral on this side. So everything via smartphone, for example, all the work order management, the commenting, how I said about the evaluation of the machine status are done via this application. And the goal of it is really trying to understand the machine downtimes. So to be able to categorize them, to be able to recognize the patterns and the connections, and also to predict and try to avoid the upcoming downtimes. So the benefit after that is, of course, increase of the OEE, and this is a very important point. Increase in production efficiency. Of course, we have worked also on different kind of subject, like for example, the online comparison of the planning with the effective production. We have a lot of customers who say, okay, I have planned something, but I have no overview about where I am right now in comparison to my planning. So with this kind of tool, is it possible to have all the data on the same screen and to understand exactly where we are at this time? The post calculation of production orders, this is also a very important point, because how can we be sure that an order will generate money at the end? Because we need to know a lot of different parameters. How long did we use the machines? How many downtimes? What are the reasons? The raw material that were used? How much? The scraps also that was produced have to be taken into account. All the tools or the MRO articles that was also used to produce this order, these are all parameters who has to be also integrated in this calculation. And this tool allows us to do it with a very precise view. Condition monitoring of all production machines. We are talking here about digital twin, having the machine one-to-one on the screen with the same parameters, so that the people having to move into the factories to check all the details of the machine, everything available on a screen. And of course, the integration of the planning data and real-time monitoring of production progress. So the benefit, creating additional factory capacities. So with the same number of machines, we were able to increase this capacity. So to be able to have a better OEE, allow us to have a better capacity, and at the end of the day, this allows us to produce more. So let's just talk about the CEO of this company. He says he chosen us because the company BRW has managed to set a new industry standard with Jellix. So we were at this time not so known as an IoT solution provider, but he has told us that he made this choice because he worked with us for many years, and he was confident about the solution. So it was a kind of a bet at this time, but I think this project was really successful. And I just pick up 3 main questions that we can try to answer within this webinar. For example, the first one is, which are the departments to involve into the digitalization? So I will try to explain in a few words, if you want to start a project at your factory, how to do it, and who are the people who have to be involved into this kind of project. So this is a picture done by IoT Analytics that we used to also try to describe the different departments that are always linked to a digitalization process. So of course, today the factories has already a lot of different kind of software and systems. And what is exactly the place of an IoT platform between all these solutions? And just to try to give an answer, if we focus on the IoT platform, here are the different departments that we often see involved into the Industry 4.0 project. So if we take the first one, we will have the people of the manufacturing. So really the operators or the production department with all the engineering, the maintenance guys, and all these people having a link directly to the equipment. Then, of course, the supply chain, because the supply chain involves a lot of different, I would say, people from the tool management side, from the logistics side, for the purchasing, for the stock management. So these are also people that are often involved into our project. Another main, I would say, unit is the quality management, quality control of the items itself that the company produce, all the measurements, but also the measurement tools which are used to make this quality control, and the final control. So this is mainly quality. And the last one, nevertheless, the process and guidance for the companies having an assembly process, for example, but also I was talking about planning, all the people having a planning department, having an overview about the work order into the whole company. This is also something that Industry 4.0 gives as solution. So we have a lot of people having this kind of department also involved. So for coming back to this use case, the company Tech3, the 3 modules. So I was talking about standard modules that we integrate to our customers. It's not custom development in this case. We just implement some modules that are available on the Jellix platform. And in the case of Tech3, it was 3 main modules. First one for the shop floor management. These are dashboards giving access to the data from all the equipment. We try to have all the data on some different kind of screens, and this generates a lot of information for the workforces. The second point is the inventory. Inventory is an application for the tool logistics and for the tool management. So having access to all the transaction, which tools were used on which work order, also delivering the tools to the operators. In this case, we work with vending machines, and all the vending machines are used with the inventory software. And the last point is quality control, quality management. We also have here connected measurement tools. So we have operators who can input the data directly from tools, no need to use the keyboard anymore, and all the process, the quality process is built up into this application. So these are 3 applications based on the Jellix platform that the company Tech3 is using right now. What are the steps of the digital journey of a factory? This is the second question. This is also a chart that we've seen for a few years ago, but we use it a lot to try to explain to our customer that we cannot jump from one day to the other to a fully automated factory. We have to go through different steps, and all these steps have their own benefits. So it's not because we just talk about connectivity, which is at the bottom of this chart, that we will not generate a benefit implementing this solution. So as soon as the first 2 steps will be done, then we can really go into the direction of Industry 4.0 with the visibility to understand what happens, the transparency to know why it happens, and then the last 2 steps are the forecasting. Of course, now the main topic are, for example, predictive maintenance and the adaptability in terms of having a closed loop, being able, for example, to correct a machine directly out of the dimension of a part which will be measured at the exit of the machine. And if I come back to this Tech3 project, the company Tech3, these were the steps translated into the implementation of the different modules. So first of all, connect all the equipment, giving access to the machines through the program transfer, then really talking about the data itself, introducing the process, really the business know-how right here was built up into the application, and then after condition monitoring for predictive maintenance, and at the last step, the quality control. So this is just an example about how did we translate these few steps of the last chart into a concrete use case. So of course, these are a project approach that we try to use always standard that our customers with the, I would say, standard project management tool. We talk about, first of all, an as-is analysis to understand exactly what are the challenges. We will do a to-be concept. We will try to work together with the customer because each factory are still different. And we cannot say, okay, just roll out 100% standardized solution. We still have to make some kind of specific requirements for each customer. And that's the positive aspect of the new technologies, is that we are allowed to do it more efficiently. Then, of course, the implementation and the rollout as an integrator, this is also our role, is to be always together with the customer during these difficult phases, and of course afterwards the after-sales support, because all solutions need support. This is the last question, what are the actual KPI that are asked by the customers? So on this side, I try always to compare it to something that maybe a lot of people already knows. I think a lot of you have already tried a smartwatch, and what do we try to do with a smartwatch? Is getting some data, some metrics, some physical measurements to be able to understand an actual situation. And at the end, it's exactly the same what we are doing in the factory. So we will try to measure, because everything that cannot be measured cannot be optimized. So we need to know at the first point, what is the actual situation? And in the shop floor, for example, we'll talk about OEE, about condition monitoring, about cycle time, predictive maintenance. So these are also parameters coming directly out from the machines. And the OEE is a fundamental and popular indicator in the industrial world. I think a lot of people talk about OEE, but why? It's because it's a KPI who allow us really to understand our actual rate. So the three components of it are the availability rate, performance rate, and quality rate. And the calculation of the OEE and its components are not so complicated. It's also possible to do it without digitalization. So we have some customers doing it by paper, because if we have access to this data, it's possible to do it. But why is the OEE strongly linked to digitalization? And I think this is because of following risk. It's because if the data collection is not automated, we have the following risk. The machine will wait for the data to be entered before to work again. We'll get some errors, we'll get imprecise data, we have no current data. And this is the risk if we work with, for example, paper solutions. So digitalization enables us to collect all this data automatically. And just comparing what is the difference between M2M and IoT, because a lot of people say, but we already have access to all this data since many, many years. Yes, but the main difference now with IoT or IIoT is that we can collect a wider range of data from different systems, but all on the same platform. And the data is then compiled according to various criteria, and this allows us to generate really information from all this data. So we can create relevant dashboards with data and indicators. The presentation and the analysis of the data is therefore more comprehensive and multifactorial. This helps to show similarities and correlation between the data. And if I have to summarize all of this, I will compare it to another topic that all of you already know, is the usage of a navigation system in a car. So we use a navigation system to know which road we have to take, where we are at this point, and where should we go. And this is exactly what we try to do with our customers in the factories, is giving them access to all this data to be able to drive the company into the right direction. So I would say the logic in behind is exactly the same as a navigation system for you in your car. So thanks a lot. I think I talked a lot. We will have now some time for the questions. I will be ready to answer it. And in any case, you will also have access to the presentation, or you can have direct contact to me if you have some specific questions. So I will give the word back to the colleagues.
Thank you very much, Raphael. Very comprehensive overview of the different projects, both on smart factory and on smart product level. We've already received quite a few questions. So at this point, I will invite everybody to type in their questions they have in the Q&A section. We have roughly 15 minutes for those questions, and we will probably not be able to get all of them in, but like I said, there's already been quite a few that's been, and I will just start to put them both to you, Raphael, as well as you, Matt, if you want to answer. A couple of questions came in around the topic of ROI and how to calculate ROI. So one of the questions was, how can the profitability of such a project of what you just showed be calculated? Raphael, maybe I think that one is straight for you.
So yeah, so if we have to come back to these ROI questions, it's not always easy to have a direct link to the ROI of a project like that. I would say it's difficult to make a very accurate return on investment calculation. So it's talking about break-even, for example, in this kind of project is not always easy. But on the other hand, the digitalization brings elements of answers in order to allow work teams to be better or companies to be more efficient. So I think if we really want to communicate, for example, we would have to be able to measure exactly the efficiency of the process before the project, And this is precisely what is difficult to do without digitalization. So compare something from a previous situation to a situation after is difficult if we don't have the figures. So just based on our experience, we know that making information available to people already allows a gain of 20 to 30% more productivity without making big changes. Just giving access to the people at the real-time data of the company.
Yeah, and I guess you're also mainly talking about a lot of the small and medium-sized companies that you work with on an everyday basis, and there's, my assumption would be there's probably more to be gained with these than with some larger companies that are already partially digitized. Is that a good assumption?
Totally. So for us, we are working a lot with the small companies, medium-sized companies, and they have a very big potential to optimize everything. So that's why also, how you said, we are really focused on this kind of customers.
We had a question from what appears to be one of those smaller companies, and they wanted to understand a bit if you are able to give more of a general cost figure for an investment that they would have to take for one of the examples that you shared with us earlier. That's something that you can discuss?
Yeah, so no problem. This I would say, after every kind of presentation, this is the first question coming on the table. I would say we are, as I said, focused on small and medium-sized companies. So we'll try to go quickly to a use case or to a proof of concept without investing a lot of money, just to show the advantage of all of this. And to give a number, just giving a number, it's possible to digitalize a shop floor with, I would say, 40 to 50 machines for a budget of, I would say, between 30 and 50,000 euro. This is a one-time fee because, of course, everything has to be connected, all the software has to be rolled out, all the project management is also included, but we are not talking about millions. So these are not huge investments to start going into direction of digitalization.
Very good. There have been a couple of questions on the topic of how those machines get connected. So one of the questions is, what kind of machine integration interfaces do you use to add new devices to your platform?
It's a very good question, because this was the main topic, I would say, 4 years ago. Everybody was talking about connectivity. I would say every machine manufacturer or equipment manufacturer has done a huge job in this direction. And now I would say that maybe 90% of the new machines or equipment are able to communicate via standardized protocols. So now our job is just being able, using these protocols, to get the data. To give an example, we talk with FANUC controllers via the FOCUS protocol. We talk to Siemens controller via the OPC UA. We can use MT Connect. We can use Profibus. We can use also proprietary protocols from Mitsubishi. So on our side, our job is to be able to talk to all these kind of equipment. But right now, with the actual technologies, we are going in a direction where everything is more easy.
And Matt, I would like to bring you in here as well. I mean, you've done some work on industrial connectivity as well. There's a related question on the topic of what are some of the connectivity technologies you see to be more popular than others. Is that something that you could answer?
Sure, yeah. So in conducting the survey, we did ask some of the end users what their protocol of choice is, both for IT and OT, and some clear leaders emerged. And I think there was a question about OPC UA on here too. And that was one of the newer protocols that I think is going to take off as long as the automation vendors start introducing it into their PLCs natively, which is something that I think they're going to maybe do kicking and screaming, because it kind of eliminates some of the proprietary nature and kind of closed systems that give them a competitive advantage that they used to have in the past. But I do see OPC UA as being something that will get widely adopted as long as the end users keep asking for it, and it'll help with this interoperability question. But on the IT side of things, Raphael, maybe you can touch on this too. We see just traditional IT protocols like SQL, HTTP, and FTP still being the main way that end users are connecting their data from the assets to their IT systems. But other protocols like MQTT are also emerging as viable ways, especially when the data goes to the cloud, because a lot of these cloud vendors have native support for the MQTT protocol, and it's bandwidth efficient, and we see those that being adopted in the data in our survey.
I think it's maybe just as a small input. Of course, the protocol itself is very important. For example, as Matt said, for I would say old equipment, HTTP, FTP are still protocols that are very known, and now talking about new equipment, a lot of new protocols are coming out, and OPC UA tries to standardize everything, and MT Connect also. But the challenge is not only getting connected to the equipment. The challenge is to get to the right data. And this can only the machine manufacturer or the asset manufacturer give us the information about where are stored the data. So that's why we have an ecosystem of partners, because we want to work with all these product manufacturers to get also their inputs about how can we get the data as fast as possible.
Yeah, and
I know we're.
Oh, sorry.
Yeah,
Can you,
sorry.
One more quick comment on that. So the protocol is one thing. The data structure is another big problem. And there's the OPC UA companion specifications and PAC-ML, and there's lots of groups that are trying to develop standards. But that's certainly a big problem, and something that we saw in the survey results as well.
Mm-hmm.
So we only have a few minutes left here, and I see there's many more questions. I'll try to group them. There's a number of questions coming in that would like to understand a bit more how Jellix compares to other IoT platforms, MES systems, and how it integrates into ERPs like SAP. So these are all three different questions, but I think perhaps they can be answered holistically, because they're all about what exactly is Jellix compared to other IoT platforms, compared to MES, and how does it integrate with ERP?
Okay, I'll try to answer it with a few words. On my side, first of all, talking about ERP, MES, these are systems that the customer will have in use in the factory, and we will never try to remove them from the process. We will just get connected to them as we get connected to an asset. So we just want to get the data out of these systems or to send them data, but we will never try to replace them as an IoT platform. This is first of all. And if I have to answer the second question about what is different between Jellix and other IoT platforms, I would say the first is that we are a completely open and I would say independent platform, which is not linked to a brand or to a product. So we are able to work with everybody, with every manufacturer, and we are able then to connect every kind of devices on this side. And if we compare to other platforms, we also have our main focus on industry. At Jellix, we just talk about industry, and we are really near from the customer. We'll try to understand his needs to be able to build up the standardized application. So just talking about industry help us really to be focused on this topic.
Very good. There's another, I know we're on the top of the hour, and I know that people will be starting to jump off right now. I will paste a link into the chat box right now. I would like to ask everybody to, if they can, provide us with feedback on the webinar, because it'll help us make the webinar better. Please wait a couple of seconds for that link. In the meantime, one of the last questions to you guys. Someone is asking, how can you overcome data quality issues? You just talked about getting to the data, but what about data quality?
If I can answer on my side, of course, the data quality is a main topic. So when we start a project, we will have to talk about the process analysis, because everything is based on data. So first of all, we have to be sure that the process is have a certain quality and that the data has a certain quality. That's why for this kind of project, for integration of solutions, we will need a project manager or a consulting company or people helping us to roll out all these solutions because of the data quality. Otherwise, if it would be easy and just rolling out applications, we would have not this problem about that data quality.
Got it. Unfortunately, we are towards the end of the webinar. I know there are at least another 20 or so questions that we haven't been able to answer. We'll try to see if some of them can be answered afterwards. If you would like to have a discussion about these, feel free to get in touch with us as well. We are happy to discuss this with you. That's why we're doing these webinars. We also want to understand what is interesting to you guys. Otherwise, I've just shared the link in the chat box. I would love for you guys to just take 1 minute, tell us how was the webinar, what should we do differently next time. It'll help us a lot. And so with that, I would like to thank everybody for attending, for presenting. Thank you, Raphael. Thank you, Matt. We hope that you, as the listener and viewer, found this useful. And again, for any follow-up questions, send us an email. The recording will be made available for you in the next couple of days. And we hope to see you soon on another webinar. Thank you and bye-bye.